Consider the function f of x is 6x 1 minus x for x between 0 and 1 and 0 otherwise. We want to verify that f of x could represent a probability density function. So all we need to do here is show that the integral from 0 to 1 of 6x 1 minus x actually comes to 1. Well, just doing this is enough to do that. It's a calculator paper, so I can use the calculator to do the integral. So 0 to 1, and then we have 6x bracket 1 minus x, and we're integrating with respect to x, and indeed that does come to 1, so that does it. We now want to express this as a cumulative distribution function. Well, what I'm going to do is I'm actually just going to copy this and then just paste it here, and let's just get rid of the limits. And if we get rid of the limits, oh, didn't mean to do that. I'm having trouble clicking exactly where I want to be. So that's better. Just remove that limit. Just remove that limit. We'll execute that, and that gives us negative 2x cubed plus 3x squared. So we've got negative 2x cubed plus 3x squared. Now that might have a constant on it, but let's think about, we need this to be 0 when x is 0, and indeed it is, so we don't need the constant. And if we try when x is 1, it will be 1, so that's absolutely perfect. So this is often capital F of x, and we know that it's going to be, so this is going to be what it is between 0 and 1. It's going to be 0 if x is less than 0, and it's going to be 1 if x is greater than 1. We now want to determine the 0.4 quantile. Now that's the point at which we have 40% of the data below that. So what we could do there is just solve negative 2x cubed plus 3x squared is equal to 0.4, and that should give us the value. At least it might give us more than one value because it's a cubic equation, but we'll want the value that's between 0 and 1. So again, use the calculator, action advanced solve, and then drag this down here and put it equal to 0.4 and execute. And I'm in standard mode, which is a rookie error. Let's execute again, and the value I want is going to be the one here that's between 0 and 1, so 0.4329. So now we want the probability that x is less than 0.8 given that it's greater than 0.2. So we know that's going to be the probability that x is less than 0.8 intersection x is greater than 0.2 just divided by the probability of x being greater than 0.2. Now if it's less than 0.8 and greater than 0.2, then it's in between. So that's the probability that x, let's just move the x over a bit, x is between 0.2 and 0.8 over the probability that x is greater than 0.2. And of course we've got the calculator to help us with this, so we can just do this by, let's just use the integral. So we've got the integral from 0.2, it might not like what I'm trying to do here, 0.8, and actually it's probably not going to like what I'm doing there, so what I'm going to do is I'm actually just going to copy that and then clear that line, and let's paste that in there and execute, and then I'm going to do the greater than 0.2, so that's between 0.2 and 0.8. Let's just paste that in below, and instead of 0.8 let's go to 1 there, and then we know it's just going to be that one divided by that one, and that's 0.8839. Last part's dead easy. Less than 2, we can just read from there, that's got to be 1.